All right, so on page 12, we're going to talk real quick about units because they're going to be super important in this dimensional analysis stuff that we're going to be doing. So you're probably familiar with the fact that scientists use a different set of units than most of us here in the US do. That's called the SI system of units, the International System of Units. And it's a worldwide standard based on the metric system. And it's really important that we use those units. Back when we were trying to land a Mars rover on Mars the first time, we actually ran it into the surface of Mars because some people were using meters and some people were using yards. So even that this day and age, in your lifetime, people made this mistake about not using common units, and it resulted in the loss of millions of dollars worth of a project. So there's two different types of units, and we're not going to test you on which one is which, but you should just be aware not all units are created the same. Base units are things that can be directly measured, like length or mass. You can take a ruler, measure length, put an object on a scale, measure the mass directly. Derived units, like the name implies, are a derived measurement from multiple measurements. You can't actually measure it directly. You have to take other measurements and then, like volume, take length, width, height measurements, multiply it all together to find a volume. So that is a derived unit. Now, you need to be familiar with the standard international units for all of these standard measurements. Time is seconds, length is meters, mass is grams. Volume of a liquid is technically liters, but in chemistry, most of the volumes we're going to be using are small enough that we'll use milliliters. We'll talk more about that milli prefix in our podcast tonight, but it just makes our liters unit, that standard unit, a little bit smaller to help us fit with the size of things we're dealing with. Volume of a solid, which we will probably never use in this class, is cubic meters. Once again, length, width, height, all measured in meters as our standard lengths. Then you multiply them together, you get cubed meters. And then the amount of substance is moles. Moles is kind of like a dozen. We'll talk about this a lot more in Unit 6. But a dozen equals 12 things. Anything. You can count how many things you have by the dozen. In chemistry, we need a much bigger number to count how many atoms, molecules we have. So 1 mole is 6.02 times 10 to the 23rd. No matter what you're counting, you got 1 mole of something, you've got that many things. So I can say I have 3.25 moles of water. That tells me exactly how many atoms, molecules of water are in that bottle. And then, of course, temperature is Celsius, not Fahrenheit. All of these are a little weird from what we're used to. Here as Americans, we have to adjust to these units when we're doing science to make sure we're communicating clearly. Now, dimensional analysis, which is most of what we're going to be focused on here. You need a calculator. Even though I'm going to do most of these calculations for you, and I'm not doing all of them, and I don't want the first time you try and plug the work that I'm doing into the calculator to be when you're doing it all on your own. If you can't get the calculator to get the answers that I'm getting when I'm setting up this problem with you and for you, then it's a calculator issue. It's not a you issue. Talk to someone next to you or send me a message and I'll try and help you figure out what you're doing wrong with that calculator. But I'll try and make it as clear as possible in these videos in order to make sure you know what you're doing and what you might be doing wrong with plugging that in. So first, dimensional analysis is a system of problem solving that we use in order to set up and solve calculation problems and conversion problems without having a set equation. So like with a percent error equation we just plug numbers into that equation every time it asks for percent error, get our answer. But we're not always going to have an equation. Dimensional analysis is a way of us solving problems without needing an equation. And the way we do that is by using conversion factors strategically. What is a conversion factor? Well, it's the fraction form of a unit equation. Technically, that purple stuff right there is all you have to write down here. But I don't think that's really explicit enough. I think you could probably understand this better if I talk a little more about, well, what is a unit equation? Just like it sounds like, it's an equation that has different units in it. But as the word equation implies, these two things have to be equal. So these are equivalent quantities, but they're in different units. Like saying 2.54 centimeters equals 1 inch. Even if you don't write down the green part, maybe writing down that example of a unit equation will help you remember what we're talking about there. So if we're turning a unit equation into a conversion factor, we're just going to turn it into a fraction. A fraction has a top and a bottom side. An equation has a left and a right side. All we're going to do is take the left side and right side of our equation and turn it into the top-bottom side of a fraction. And as you might imagine, because there's those two different sides, there's two different ways we can take a unit equation and turn it into a conversion factor, just based on whether we put the left side or the right side on top. So, for example, with that 2.54 centimeters, equals 1 inch. If the centimeters part is on top and the inches are on bottom, that's one conversion factor we can make from that equation. Or we can put the inches on top and the centimeters on bottom. That's a different conversion factor that we would use in a different type of problem. Both of these are coming from the same unit equation, but they're not going to be used for the same type of problem. And one thing I want to point out here before we move on, notice how it's not just all about the numbers. We are doing math. The numbers will be important, but the units are going to be the most important part of our dimensional analysis in terms of setting it up and getting the numbers where they need to be. So we've got to include our units in every single conversion factor. Every single number needs a unit from here to the end of this class and, in the future too. So we're going to do conversion factors to convert numbers in dimensional analysis in this process. And when we're converting, the unit we're trying to cancel is always going to be placed on the opposite side of the conversion factor from where it's starting. So most of the time, because our dimensional analysis process will start with numbers on top, that means that the opposite side, the one where we're trying to put things to cancel out what we've got in the next kind of bracket, in the next conversion factor, is going to mean we want to put the units we're trying to cancel on the bottom of our conversion factor. That's going to be real important. And this kind of makes sense if you think about this as math. If we were trying to solve something like 3x equals 6, if I want to cancel out that 3 that's being multiplied by x, I would divide by 3. I have a 3 on top, so I'm going to put a 3 on bottom so they cancel out. Now in math, you'd have to do that on both sides and keep doing some algebra there. We're not actually going to be canceling numbers. Like I said, we're canceling units, but the idea is the same. If I've got a unit on top that I want to get rid of, I'm going to put it on the bottom of that next bracket. Now, quick slide, nothing to write down in your packet, but I want to explain to you why when you see me working problems, you're going to see me writing ESS a lot. That's the last 3 steps of the guess method, GUESS. The G and the U, I generally just highlight in the problem. That's our given, the number I'm starting with. What do I have to start the problem with? And the U is our unknown. What are we looking for? They're both part of the question, so I tend to highlight or underline them in the question. But then the E step, the first thing I start writing out, that if you got space for it, it would be great to help you with, is to write out your equations. If we can see all of the unit equations we've got, then all we've got to do is decide which way to rotate them to turn them into the conversion factors in our dimensional analysis. I think it really helps people to see that option, see the equations before we're putting them into our conversion factors in dimensional analysis. The one non-negotiable, what I need to see on everybody's page, is the substitution step, that first S step. That's the dimensional analysis work. That is non-negotiable. Even if you can work these problems out some other way, we are going to start with some pretty simple problems that you might be able to work out without showing any work. You have to show the dimensional analysis to get credit. You will get 0 credit on tests and quizzes if you do not do it with dimensional analysis. So, like I said, the beginning problems we're going to give you might be easy enough for you to do without, but they're going to get to a point where you physically cannot do this without dimensional analysis. So we need to learn the process for those hard problems before we get to those hard problems. The second S is for solution, or the solved answer. So I always go through, and you will see me write out the ESS steps. Feel free to do the same, but at the very least, like I said, dimensional analysis setup and the answer. Now, this first problem I am going to work out real quick. It's not in your packet. I don't want you to be so focused on writing things down in your packet and copying from this video that you do not actually understand what's going on or why. So, I wouldn't know if you skip ahead to the next one. But that being said, watching this process happen and just kind of going through this process with me is really going to help you in the long run. So I'd really recommend put your pencil down for a second and just focus on what I'm talking you through on this screen so that you understand the whole concept of where we're headed with these problems before I even ask you to do one on your own. So in this question, I want to know how many M&Ms we would burn off while running a full marathon, which is 26.2 miles. It's known the average person burns 310 calories for every 3 miles they run, and there's 140 calories in a serving of M&Ms, which is 32 pieces. So the first thing you focus on is finding that given and the unknown, and they're always part of the question. So it's asking us how many M&Ms. That is my unknown. That's what I want to get as my answer to this problem, is M&Ms. And what I've got, the one thing I know is in front of me, is a marathon, 26.2 miles. That is my given. All the rest of the numbers here in this problem are actually part of some kind of little sneaky unit equations, telling us that there's 310 calories burned for every 3 miles we run. 310 calories equals 3 miles. And 140 calories in a serving of M&Ms, which is 32 M&Ms. We can say 140 calories equals 32 M&Ms. Now we've taken out just all of the kind of junk words and just connected these two unit equations to each other. So this is the part that you will always have to write down. And the dimensional analysis, at least my process, always starts with a line. We're going to be organizing our conversion factors and our given information on top of and below this line. So I always start with my line, and then we write our given on it, 26.2 miles. If you'd rather start with the number and then draw the line underneath it, you can, but one way or the other, this is where we start. So at this point, what I've got, my given, is 26.2 miles, but I don't want miles. I want to cancel out miles and turn this into M&Ms by the end. And if what I'm looking at is miles, and I want to cancel out and get rid of miles, then when I'm looking at my two unit equations, the green one and the blue one, it's the green one that I'm going to use first, because it's the one that has miles in it. And the only way to cancel out the miles I've got is by putting miles on the bottom of the next bracket. So remember, we're going to turn this unit equation into a conversion factor. And there's always two options for how to put this into a conversion factor. But we want to use that first option because it's the one that has miles on the bottom. So we're going to put the 3 miles on bottom, 310 calories on top. We need to keep those two equivalent quantities vertical with each other, just turning the equation into a conversion factor here so that our miles will cancel out. And because I've got miles on top and miles on bottom, they're canceling, not the numbers. The numbers are still there. And if we kept those numbers there and calculated now, all I've got left, the only unit I have, is calories. So we'll talk more about the calculations in a bit. Don't worry about that right now. But if I stopped now and calculated, this would tell me how many calories I burned during that 26.2 miles. But that's not what I want to know. I don't care about calories. I care about M&Ms, which means we're not done yet. So if I'm looking, both of my equations have calories in them, but the green equation would take me back to miles. That would not help me get to my M&Ms. The blue equation can get me straight from calories to M&Ms. So we are going to go ahead and be using that blue equation to cancel out our calories. And when we have this choice, we always have a choice when we're looking at that equation of which way should I set up my conversion factor from that unit equation. Because we're trying to cancel out calories, this time we're going to use that second conversion factor, the one with calories on bottom. And now, not only are our miles canceling out with each other, but because I have calories on top and on bottom, they're canceling out together, and all that I'm left with is M&Ms. And that's what I wanted. I wanted M&Ms. What I think of is at the end of our dimensional analysis, up on top, whatever's in this top right corner is what we're going to end up with as our units on our final answer. And M&Ms is what we want to end up with. So we're done setting up dimensional analysis. We have all the numbers still there, and M&Ms is our final unit. So now it's time to calculate. And the way we calculate, I already kind of started trying to show you earlier, but I didn't want to confuse you too much. We've arranged these numbers carefully. So now we're just going to multiply whatever numbers are on top together and divide by whatever numbers are on bottom. And I know it might be weird, but I would highly encourage you to put your entire dimensional analysis setup with all of its numbers, all 5 of these numbers, into your calculator at once. Meaning put 26.2 times 310 times 32, don't push enter, divided by 3 and divided by 140. If you do that, when you push enter, you should get something like 618.819047. If you're not, you're plugging it in wrong. And the reason I want you to put it in all at once is because if you're not getting this, you can use the little arrows on the calculator, push the up arrow. That'll take you into the last thing you typed. And then you can use the left and right arrows to go over. See if you dropped a decimal or you dropped a single number in there. Sometimes the 0 or the 1 just sticks because we use them so much. So if you type it in all at once and you don't get the answer I have on the screen or the answers I have on the board, then you can easily go back and check everything all at once. If you did this in multiple different steps, you did 26.2 times 310, pushed enter and got a number, then times 32, enter, then divided by 3, enter, divided by 140, enter, and you get to the end and your answer doesn't match mine, you don't know where you went wrong. And even if you do arrow back up through all of your previous math and find where you went wrong, you still have to start from the very beginning. You can't just arrow over and fix it. So, really recommend you just put it all in at once. Push the multiply sign between numbers on top, push the divided by sign between numbers on bottom. It doesn't even technically matter what order you put them in if you're doing the right sign before each of them. And that gets us our final answer. Well, our almost final answer. Here, we have a lot of digits, and you're probably hoping that we don't need to write all those digits out, and you would be correct. And even though we've got 5 numbers coming together into this answer, the only one that matters for rounding our final answer is the sig figs in our given. Since that has 3 sig figs, we just want to keep the first 3 sig figs in our answer. So 618.8, that second 8 is going to round the first one up, which gives us our final answer of 619 M&Ms. So hopefully you can see the power in this process and how we can solve random questions. There is no formula for how to calculate M&Ms from miles, but by taking a couple of simple equations, information from the back of a package of M&Ms, we can put those ideas together and calculate this out and be confident in our answer, because as long as we know that our units on those diagonals match and are canceling out, and the things that are vertical above each other are equal to each other, those two things helping organize our process, anyone can understand and follow your math and agree with this answer. It's not just a random set of calculations and multiplying and dividing and your kind of scratch like margins where someone has to trust you're doing the right things. This is a way of proving that this random multiplying and dividing is actually systematic and getting you the right answer. So let's do a simpler problem that's actually in your packet. We're going to convert 358.3 inches to feet, and hopefully you are confident in an equation that can help us get there. There are 12 inches in 1 foot. That should be all we need to convert from inches to feet. So if we're going to do this in dimensional analysis, which you have to do in order to get credit, even for these notes here, but especially on tests and quizzes, we're going to start with our given 358.3 inches and set up our line for our dimensional analysis process. Just trying to make that a little straighter there. Now, since I have inches on top here, that means I know no matter what else, I have to have inches on bottom. So if I only have one equation to choose from, that means 12 inches has to go on the bottom. And if that 12 inches went on bottom, the other half of my equation, that 1 foot, goes on top. Now, I did make my line a little long, but we can always erase that, make a little extra space for our final answer. If you would rather start off by just drawing the short line and then making it longer, you can. But, you know, the not meeting up and not being straight kind of bothers me sometimes. So I just try and start with a nice straight line. So if we do that division, and I know you can take the 358.3 times 1 and divide it by 12, but most of you are math literate enough to realize that multiplying by 1 won't really change the answer numerically. So if you want to save yourself a couple of button pushes, I'm not going to be watching you over your shoulder for how you plug it in, as long as you numerically agree that our final unrounded answer is going to be 29.8583 repeating. And if we look back at our given, this is 4 sig figs here. So we want to keep the first 4 sig figs in our answer. So 29.86 is going to be our final rounded answer. And I'm just going to abbreviate that FT for feet because it seems a little silly to write foot. It's more than 1 foot there. So that is our final answer here. And like I said before, this is probably easy enough that you could probably find this answer, even round it correctly without dimensional analysis. But we are going to get to some problems, maybe not even in this unit, but we're going to use this throughout the year, and we will be building and making this process longer and more involved and more connected to chemistry as we go. And eventually there's going to be a point where you got to use dimensional analysis to be able to get the right answer. So let's do the next problem together. This one asks us to take our answer from the previous question, so that means 29.86 feet, and to turn it into yards. So I don't even need to write out an equation because it's sitting right there waiting for us. So we're just going to start with that 29.86 feet, making sure you need to work out this using dimensional analysis. And if this is our conversion factor, that's our equation, since I've got feet on top, I'm going to put the 3 feet on bottom, 1 yard on top. That's it. Our feet match up, so they're canceling out on that diagonal, leaving the numbers behind, along with the yards that we've got and that we want. So if we plug this into our calculator, taking that 29.86 divided by 3, we're going to get 9.953 repeating, and we still want to keep 4 sig figs. So our final answer here is going to be 9.953 yards. Make sure that every single space of your dimensional analysis has units as well as your final answer. Real quick kind of detour into points on a test. You're going to get a point for having the number and the unit in each space of your dimensional analysis. Your answer is going to be worth 2 points, the value being correct and the sig figs of that answer. Then 1 point for the units on your answer. So if you've just forgot to write yards at the end, which sometimes happens, you're so done with the problem you're ready to calculate, you're not going to get that point. If you don't use dimensional analysis, you're not getting any credit for anything that you do. But even if we did give you partial credit, you would be instantly losing half of the points for this problem because you're not using dimensional analysis to show your work. So even if we're generous, you're getting half credit, and that will add up real quick. But in specific quizzes and test questions that tell you to use dimensional analysis, you would just get no credit if you don't use that process. Now, this third question is meant to help you see, if you hadn't already seen my example earlier, how we can set up multi-step problems. So when I say directly into yards, I don't mean in one step. I mean, I want you to use those same 2 equations that we just used in the first 2 problems. 12 inches equals 1 foot, and 3 feet equals 1 yard in order to do our converting here. So we're going to start with that 358.3 inches number. And since inches is what we've got to use our blue equation here, which has inches in it. It's the only one that has inches. And keep in mind, those inches have to go on the bottom to cancel out the inches we started with. That means the other half of my blue equation has to fill in the top part of that bracket. They always stay together. We're just rotating that equation so one part is on top or on bottom. And this is where we stopped in the first problem, but we're not done here. Here we want to go all the way to yards, which means it's time to use our red equation. And because we have feet on top here, we're going to take the feet part of this equation, just like we did in problem 2. Put 3 feet on bottom, 1 yard on top. So here we've taken each of those conversions that we did separately before in 2 separate problems, and now just use them sequentially in order to work out a multi-step dimensional analysis problem. And if you multiply all of these numbers across the top, which you don't necessarily have to write or push the buttons for times 1 and times 1, but you divide by 12 and you divide by 3, we are going to get as an unrounded answer a slightly different number than what we got in the previous question. But if you notice, we're only keeping 4 sig figs, which means the 7 is going to round our 2 up. So our final answer here actually ends up being exactly the same as our previous answer, which means that if we follow significant figures, then there's no significant difference between these processes in how we're doing this calculation. We end up with the exact same answer. Even though our unrounded answer looks a little different, it's not significantly different because once it's rounded to sig figs, it's the same. So let's make our process go a little bit longer as we go to the next page. this is going to have 3 separate conversions, and as we read through, you'll notice them. This says, before the use of money, people bartered for goods they needed. If 25 chickens could be traded for 1 pig, and if 10 pigs could be traded for 1 cow, and then if 2 cows could be traded for 3 horses, how many horses could be exchanged for 1,500 chickens? So notice how here, the question's at the end, but it still has our given 1,500 chickens. That's what I got. I'm trying to get rid of them. And what I'm looking for, my unknown, is how many horses can I get for all these chickens? So I want to turn chickens into horses, and I'm going to do that using these 3 equations that I've highlighted. If I go ahead and summarize them down here, and I'll keep them the same color as I highlighted them, and I did go ahead and abbreviate chickens because that's going to take way too much space to keep writing, and I will run out of space at least. Feel free to make your own little shortenings of these units, because everything has to have units attached to it. Just be careful if you narrow it down to just like C for chicken, you're going to have a problem with cows as well. So maybe CH and CW, something like that, but whatever works for you. So these are our 3 unit equations that we're going to use for our conversions. And if our given is that we have 1,500 chickens, that should be the first number that we start with. That's the first number we put on our dimensional analysis line. And then if we go looking for chickens, because we don't want chickens, we want to cancel out chickens, it's only that green equation that has chickens in it. And so we have to put those chickens on the bottom of this next bracket, which means that 1 pig, the equivalent quantity, the other side of our equation, fills in the top. But I don't want pigs. That's what I got. If I stopped now, I'd have pigs. Chickens have gone away. But if we don't want pigs, we want horses, we have to keep going. And the blue equation is going to help us get rid of pigs and get to cows, which we still don't want, but we can see cows can get traded for horses. So we are going to go next to our blue equation, making sure to put 10 pigs on bottom. That means that the 1 cow fills in the top. And then purple equation time, making sure to put those 2 cows on bottom so that we can end up with 3 horses up on top at the end. And you don't have to highlight them, you don't have to cross them out. But when I'm done and I think I'm ready to calculate, I always check my diagonals just to make sure they match up. So they're canceling out, and what I'm left with is what I wanted to end up with. So there's a few more numbers here, but we still just multiply all the numbers across the top, push divided by as we plug in all those numbers across the bottom. And what our calculator should give us for plugging it in right, and I really want you to try plugging this one in especially, is 9. If you're not getting 9, ask the person next to you or ask me next class about your calculator issues. It's not you, it's the calculator. But that is our unrounded answer. 9 seems like a nice number, but if we look back at our given, this has 2 sig figs, not 4. Those zeros aren't sig figs because there's no decimal in the number. So, in fact, our final answer to the correct number of significant figures would be 9.0 horses. We have enough chickens to get exactly 9 horses. And if that's something that we want, we need to bring every one of those chickens to market. Can't lose any along the way. So, hopefully this process is making a little bit more sense now. I am going to ask you to start doing more and more here. This next problem I'm not going to work out on the screen. I am going to help you find the equations, highlight this problem just like I did with the last one. So we're trading cars, and evidently 1 Maserati is worth 3.5 Porsches. I just used Maz and P for Maserati and Porsche. 1 Porsche is worth 5 Jeep Wranglers, and then 2 Jeep Wranglers are worth 15 Ford Pintos. If I collect 225 Ford Pintos, that's our given. That's what I've got, which means that's what you should be starting with on your line. 225 Ford Pintos, or FP for short. How many Maseratis would they be worth? So I'm starting with Ford Pintos, trying to get to Maseratis. And so you've got these 3 equations. I will tell you now, it is up on the board, but your final answer should be 1.71 Maseratis if you're doing this correct. That's a correct final sig figs there. Now, if it hurts your heart a little bit to see these fractions of a Maserati, promise you I'm not taking a chainsaw to any Maseratis to cut them up and trade them. That just tells us if we were really looking for 2 Maseratis for me and my BFF, then maybe I need to keep saving up. If I was just looking for 1, then I don't even need to bring all those Ford Pintos to market. I could probably get what I needed with fewer. So make sure you are setting up your dimensional analysis work here, making sure to match those units on the diagonal, cancel out what you got until you get Maseratis. Hopefully you get 1.71 just like I did. Now, the next few problems, especially number 6, go ahead and add a decimal to the end of that 500 number that's your given in that problem. That's why you probably see on the board my answer has 3 sig figs. A lot of people forget to do that and then they think I rounded wrong. I never want you to round down to 1 sig fig. That's just such a poor estimate. That's not even really a measurement. So I'm always going to do my best not to give you 1 sig fig, and there I didn't do my best. So add a decimal there to make it 3 sig figs. Do your best to set up and work that out. Got the answers for 7 and 8 here, and with 8, it bothers people the rounding. You're going to get 86,400, and my answer is 86,000 because I rounded to 2 sig figs. So go ahead and look at these next few problems on your own. If you're not getting the right answer, come check it with me or the sub or whoever is there to check it with. And I want to work 9 and 10 for you real quick before I go. So these are a little bit different. There's a little bit something special going on here. And you might think, oh, inches to feet, that's easy. 12 inches equals 1 foot. But what you should notice is that these are squared units, which means that we can't just use a simple normal inches and normal feet. And it would be kind of nice if all we had to do was add squared to the units and then our equation was fixed. But that's unfortunately not the way it works. But it's pretty close to that. Like with most other things in the equation, if you square one side of the equation, you got to square the other. Well, if we square the units, we also have to square the numbers. So we're going to square 12 and 1 in addition to the inches and feet. Now you could technically use this as written and plug into your dimensional analysis 12 squared, so you can take your given, divide by 12 squared, and your calculator is going to do the rest of that math. But a lot of people kind of are bothered by seeing all of that math there in their dimensional analysis. So let's go ahead and do the math. You could probably do this in your head. What is 12 squared? 144. So there's 144 inches squared. The inches are still squared. We already squared the number, but along with it, those inches, the units get squared too. And then the 1 gets squared, but 1 squared is just 1. And then our feet are still marked as squared. This isn't telling you to square the number. That's the squared on the unit. When the squared was on the number, we had to change the number, but we already changed that here. And that's all that there is to it. That's the only special thing that's happening here in this problem. Now that we have an equation with squared inches and squared feet, we can take our given, and you could put, like I said before, 12 squared inches squared down here, but most people like to use the purple version of this. Take that already squared number. So 144 inches squared have to go on bottom because we had inches squared on top, which means 1 foot squared goes on top. And our unrounded answer is 11.5208, which we want to keep 3 sig figs for because the 1, 6, and 5 are sig figs. The 0 is not because there's no decimal. So that just ends up being 11.5 feet squared, or square feet. Hopefully that's not too bad, but everyone always forgets how to do this when we get to a test, which, spoiler alert, there's going to be one of these on your test. So even if you haven't been writing down the equation step in all these other problems, I'd encourage you to write it down here so that your future self can look back, remember how we came up with these weird equations in order to solve the squared unit problems. The last problem that we're going to work out here is what I call a combined unit. We're trying to look for the fuel efficiency, miles per gallon, how many miles we can make it in every gallon, if our car from Europe goes 10 kilometers per liter of gasoline. Notice how in each of these units, those are units for a single number, but there's kilometers and liters, there's miles and gallons. They've been combined together into that single unit for that number. So this is going to be a little bit complicated, but not really as complicated as you think. And I've given you all of the conversion factors that we need here. So the key thing when we have those combined units, write out your given, get ready to put your line here. But notice how we have this line, the slash going through our units here. We're going to make sure that when we put our dimensional analysis line on our given, that dimensional analysis line goes through our given units as well. So that kilometers are on top with our given number, and then the liters are on bottom. There's no number that goes down here with the liters. It's technically part of that 10 kilometers per liter. We're just separating it from the kilometers so we can do two separate conversions, but just focus on first getting kilometers to turn into miles and then getting liters to turn into gallons. It's all going to be on the same dimensional analysis setup, but we can focus on them one at a time if we have them split up like that. So let's go ahead and focus on those kilometers first, turning kilometers into miles. So we're going to have to use this green equation, and as you probably expect with kilometers on top, we want to put the 1.61 kilometers on bottom, which means that 1 mile goes on top. Now our kilometers and kilometers are canceling out, and if we stopped now, our answer would be how many miles per liter, miles over liters. But I don't want liters, I want miles over gallons, so we're not done yet. We need to use our red equation to turn our liters into gallons. And the one tricky thing that happens at this point is because liters are on bottom of that given bracket, to cancel them out in this next bracket, which is kind of a long term, just kind of ignore this for now. It's there, but it needs to be there to turn our kilometers into miles. We're doing kind of a long distance canceling, but if those liters are on bottom, then we need to put our liters on the top of this final bracket, which means that that 3.77 number is going up top, and then 1 gallon is going on bottom. So our liters are also canceling out just like the kilometers were, and what we're left behind with is miles over gallons, which is what we wanted. That's our unknown. So if we go ahead and calculate this, we get 23.416. Keeping 3 sig figs because those zeros are significant. We get 23.4 miles over gallons. And you can do them straight over each other, or like they are written in the problem, you can make that more of a slash. So if you just watched this video straight through, make sure you go back and do questions 6, 7, and 8. Those are your responsibility, maybe even 5. You might have skipped that because I didn't do that. You need to finish those problems. Check your answers with the answers that I have posted and ask if you have questions on any of them.